Hi, this is Teacher May, and I'm from the Philippines, and I am so happy that you can be with me in this wonderful time and going to learn about the subject that I'm very passionate about, that is science. So before we proceed to our class, Nate, can you hear me? Do the thumbs up sign if you can hear me. Great. How about my visibility? Am I visible? Do the thumbs up if I am visible. Okay, good job. I would like to ask you, Nate, about if you know what a roadmap is. Good job. So a roadmap tells or has an illustration of directions of places or locations. Nate, do you know that scientists have what we call roadmaps? So this roadmap, this what we call roadmap for science, is actually a very useful tool for scientists to be able to answer questions and solve problems. And you are right. That is the scientific method. And that is our lesson for this morning. So scientific method. So these are series of steps that scientists use to answer questions and solve problems. 6 steps in the scientific method. Again, what are those? 6 great farmers plant all day. Getting the initials of each word will also give us the steps in the scientific method. So let's start with S. So the first step in scientific method is state the problem. Of course, before we start an experiment, you must have a reason to do it, to identify the problem to be solved by answering a question. So one good example of stating a problem is this. How do new living things or organisms come into being? So that is a very good question. These are examples of testable questions. So does the amount of sunlight a plant gets affect how it grows? Or another good example of a testable question is, does the size of the hole in the bottom of a sinking water clock affect how fast it sinks? Opinions, on the other hand, are not testable questions. Like, is Michael Jordan the best athlete of all the time? So that is not a testable question. Is a dog happy if it wags its tail? So that is also not a testable question. We're done with the S, which is state the problem. Number 2 is G. So what's G? Very good, Nate. That's gather information. No good scientist would be able to do an experiment without gathering information. So the scientist researches the subject that he or she is studying. So scientists can make observations or draw inferences based on the data or based on the researches that he made. So Nate, do you know where to conduct researches? Yes, that's right. We can conduct research in the library, in the internet, television, and many more. We can actually have journals to be read. Okay, we have online journals, published journals, and many more. So that's gather information. Okay, third is form hypothesis. So what is hypothesis? Hypothesis actually is an educated guess. It could be a possible explanation. For centuries, people believed that life came from non-living matter. So an example of this, when maggots came from meat. And scholars for many centuries call this a spontaneous generation. But it was an Italian physician in 1668, Francisco Redi, who observed that maggots appeared on a meat a few days after flies had appeared. So he thought that flies laid eggs too small to be seen, and his hypothesis therefore was flies produce maggots. How are we going to write a well-written hypothesis? Yes, A well-written hypothesis consists of an if statement and a then statement. So the if statement is what you are testing, and the then statement is your belief of the outcome of the experiment. Or if caffeine is increased in someone's body, take note, if caffeine. So where or what are we going to test in this statement? The amount of caffeine increased in someone's body, then their reaction time will be quicker. The statement there, the reaction time will be quicker, that is our belief of the outcome of the experiment. So now we have P, perform experiment. After we have written our hypothesis, we are now going to test if our hypothesis is accepted or rejected. So scientists develop a way to test their hypothesis. So of course, we have this called what we have variables. That these are factors that can change in an experiment. Okay, we can have equipment, temperature, time. Hypothesis tested by experiment where only one variable is changed at a time. So all other variables should be kept unchanged. That is called a controlled experiment. And for variables, we have this what we call the independent variable and the dependent variable. So an independent variable is the variable that is changed. So what is being tested? And then the dependent variable is what is the result observed. So Reddy designed his experiment, the Italian physician that we are talking about earlier. So he designed an experiment. So like this, he took 2 jars, one jar that is left uncovered, and there is another jar wherein he covered the jar with the meat inside of it. Now he designed his experiment. What do you think was the independent variable? What is being tested? What is the dependent variable or the results? Yes, the maggots. So what did Reddy found out in his experiment? So after doing the experiment, he will now analyze the data and record results. It is very important, Nate, that scientists compile data into charts and graphs, because one characteristic of a scientist is being organized. So as a scientist, you should be organized because this helps make sense of the information taken from the experiment. So what did Reddy do? You're right. So Reddy recorded his data. Copies of his work were available to later generations of scientists. That is for future references. Good job. So what are the results of Reddy? Can you guess, Nate? Very good. So the results of Reddy was that there are maggots that appeared on meat in uncovered jars. And there are no maggots present when the jar was covered. With goes. That is correct. So that he analyzed the data. After recording the results, he will then now draw conclusion. So scientists in conclusion or drawing conclusion, this is where scientists decide whether the hypothesis was accepted or is correct or not at all. So Reddy's results supported his hypothesis. His experiments were reproducible. So if repeated, results should always be the same. And scientists should also know how to communicate results by publishing a report in scientific journal. How is the scientific method used? It is not used only in school, but also in other departments or agencies, like in forensics. So I hope, Nate, that you have learned something today and you can use the scientific method for yourself in order to solve your own problems. Keep safe and be curious always. Goodbye. See you next time.